Okay, nearly there. 3 more to go. So this section I've written, this section typically contains questions that will be more challenging than those required by a time-limited IGCSE exam. However, my expectations are that students aiming for a grade 9 will be able to attempt these with the constraint of the time limit removed. So these are slightly more involved tasks about, well, this first one is about implementing like diseased plants. It does not mean that a similar problem could not come up in your exam. It just might be less complex. So it could be a variant of this problem, but one that is slightly less complicated. So let's look at how we would do this. So a new feature simulating disease is to be added to the simulation. Each year, the user is asked to enter the chance that disease will spread amongst the crops, represented as a percentage figure. Enter chance of disease. Okay, there will be 5% chance of disease this year. Amend the simulate 1 year subroutine to ask the user to enter the disease chance before starting to simulate seasons. All right, let's have a look at doing that. So simulate 1 year. It's not asking me to make a new subroutine for that. So it just needs to happen at the start of, before starting to simulate the season. So let's put it at the very top of the so this variable disease chance will come from a user input into chance of disease. There's no validation requested at this stage. So the validation is optional. The question is not asking you to validate that the percentage entered is sensible. So obviously the minimum value for a percentage is 0. The maximum value is 100. But we're not going to worry about that because there have been several questions where you are being assessed on, okay, can you write like a validation sort of routine? This is not that. So let's just skip. Let's just assume the user enters something that is a valid number between 0 and 100. And that's part A done. Part B, a diseased plant is to be shown on the simulation with the character skull. So something that we'll need to do is add in a new constant. Let's call it disease. With the skull emoji assigned. Throughout the year, if a plant is next to another diseased plant, the chance of it also becoming diseased doubles. Disease spreads most virulently throughout the summer season. During the summer months, the percentage chance of a plant becoming diseased doubles for every additional diseased plant that is adjacent to it. Every spring, any diseased plant that is still alive has a 50% chance of healing and a 50% chance of dying. Some examples are shown below. So you can see here we've got a plant and the disease chance is 5%. But the disease plant is far away. It's not directly adjacent to it. So adjacent is 1 square around the perimeter around the plant, right? In this case, it's autumn and there's 10% of disease. But there is 2 diseased plants around the perimeter of the plant. But because it's autumn, the disease chance is still only 10%. Remember that during summer, the disease spreads more rapidly. So you have to work out this calculation in the summer season. If you have a look here, we've got around the perimeter of the plant, there are 4 diseased plants. The initial disease chance is 10. So we need to double it for every additional diseased plant. So there's 1, double it once, double it twice, double it 3 times, 10 to 20 to 40 to 80. So this is going to be the slightly trickier part of counting around the perimeter of the plant and then working out how to double the disease chance, but only in the summer season. Write a new subroutine, simulate disease, that accepts three parameters: disease, chance, field, and season. Let's just do it here. So let's say def, this one, disease chance, and chance, the field, and the season. And the subroutine should return a single value number of diseased plants. So let's return the number of the value. So what's the kind of thing we need to do? We need to take the field, we need to, if the season is summer, we need to count the, I guess we need to go through the perimeter anyway. So we need to go through the perimeter of each plant and count the diseased plants that are adjacent. Diseased plants adjacent plant. And then we need to say something like work out how disease spreads based on current season. So that's the kind of stepwise refinement, so breaking it down into steps. So to get each plant, I guess before that we need to go through each row in the field, and we need to go through each plot on the field and check if the current one is a plant. Does this plot have a plant? And then we need to go through the perimeter of the plant, counting the diseased plants that are adjacent to this plant, and then doing the next bit of working out. So there's slight repetitions here. So we've done the iteration through the field before, right, using this nested loop, and you will see it in the exam board's code. So what should we do? Let's copy the nested iteration from the read file subroutine. Let's delete the bit to do with the file, and then just leave what we've got. We need to go through each plot on the field. That's what we're doing. Does this plot have a plant? So the current plant will be, the current plot will be the field at this row at this column. Does this plot have a plant? So if this plot has a plant, is this plot equal to a plant? Then we need to go through the perimeter of each plant. So if you've got to know the skeleton program, you will know that there's already part of the code that has this algorithm in it. So think about how Simulate Autumn works when the seeds spread around the plant. We've already got this algorithm of checking each of the spaces around the current plant. So let's just copy and paste that. Let's take it from the other subroutine where we know there's that feature already in place, and think about what will be the same, what will be different. So these are going to be my coordinates. And what might be helpful here is for us to make like a helper subroutine, so like check for disease. Let's make a variable to count the diseased and adjacent plants. And let's make it so that every time I'm going to check around the perimeter using check for disease, and I'm going to increment the value of diseased and adjacent by the value returned by my helper subroutine. So even though the question doesn't ask you to create this subroutine, you are free to create additional subroutines if you think it's a better way to solve the problem. So we've got the current row, which is the current plant. This would be the top left-hand corner. This would be directly above. This will be the top right-hand corner. This will be to the left, to the right, the bottom right-hand corner. Sorry, the bottom left-hand corner, the directly below, and the bottom right. So using something from the Simulate Autumn subroutine, I can kind of do this thing of like checking the perimeter. Could you do this in other ways? You could use a loop. You could loop through the positions around the parameter. But if the exam board is kind of exemplifying not using a loop, and just checking one by one with like 8 sort of repetitive statements, then you can assume that that's fine, right? So what do we need to do inside the check for disease subroutine? Well, we've got a field, and we've got a row, and we've got a column, and we need to check, okay, does this contain the disease emoji? If it does, then we need to return 1. If it doesn't, we need to return 0. There isn't anything to count, right? So I've written this helper routine that will either return 1 to add 1 to this variable, or 0 to add nothing to this variable. And once we've gone through all 8 possibilities, 1, 2, 3, 4, 5, 6, 7, 8, then we will have the total number of diseased and adjacent plants. Can you spot anything that could potentially cause a problem here? So the simulation can run to the point where the plants spread to the bounds of the grid. So we don't want some sort of potential problem where we get an index error because we're trying to check the perimeter of this plant, and this would cause a crash here. So we don't have to debug this later, let's put in a feature for this. We probably need to make sure that the row is still on the grid, right? So if the row is less than 0, or the row is bigger than the field length, bigger than or equal to the field length, because the last index will be 1 less, right? Then we can just return 0, because that's an invalid coordinate, if you like. Otherwise, if the column is, use elif here because they can't both be true. Otherwise, if the column is less than 0, or the column is greater than or equal to the field width, which would be 1 more than the maximum index, then we can return 0. If we haven't returned 0, then proceed to this next bit of checking, okay, we've got a valid row number, we've got a valid column number. We can now go on to check inside the grid whether that cell or that plot, if it's a field, contains the disease character. Okay, so I did say that this one was quite challenging. So we've done the going through the perimeter of each plant. And let's think now. We have counted the diseased plants adjacent to this plant. I guess we only need that variable if the plot does contain a plant. Now we need to work out how disease spreads based on the current season. So as long as we have found disease, as long as there's at least 1 diseased and adjacent plant, we then need to decide, okay, if it's summer, we need to do one thing, and if it's not summer, we just do another thing. So the idea is that if it's not summer, disease chance just stays the same, right? If it is summer, let's just go back to the instructions. If it is summer, we need to double for every additional diseased plant. So in the example, there were 4 adjacent diseased plants. So we doubled the initial disease chance 3 times. 10, 20, 40, 80, remember? So how do we double the number? So we can say we could do, well, think, what have you learned on your syllabus? It's a nice opportunity here to learn something from your kind of paper 2, to utilize something from your paper 2 learning, right? How can we double the number? We can use a bitwise shift to do that. If we want to double it once, we do this. If we want to double it twice, we shift it twice. If we want to double it 3 times. So what should this number be? We need to do it for every additional diseased plant. So do you see if we shift the number, disease chance, disease chance is the disease chance doubled by however many diseased and adjacent plants there were minus 1. And this will be doubling for every additional diseased plant. Doubling for every additional diseased plant. What else do we maybe need to consider? Well, disease chance could come in as 100. And if we double it 3 times, then we would get 200, 400, 800. And we can't have 800%. So at that point, we probably then need to check, okay, if the disease chance has gone beyond the maximum, which would be 100, then let's just set the disease chance back to the maximum, which is 100. Okay, so we don't actually need to do anything here because if it's not summer, the disease chance just stays the same. Now we just need to work out how disease spreads based on the current season. So the idea is there's a chance of the percentage chance, the chance of it becoming diseased doubles. Oh, hold on a second. So at the moment, we're only going to so the disease still happens even if you're not next to a diseased plant. So it will be 5%. So, and in this case, let me just do this according to my confusing requirements. All right, so we need to decide if this current plant should basically say, should this current plant become diseased? So if, how do we make something happen at random, or a random probability of something happening? So if we've got a random number generated between 0 and whatever the disease chance is, or generated between 0 and 100 rather, and if the random number is bigger than the chance of the disease, so for example, if we randomly generate 50 and if it's in fact smaller than the disease chance, this is true. So say the disease chance was 100, then that would be true. If the disease chance is only 40, then 50 being less than 40 is false, so the plant wouldn't turn diseased. We need to, at this point, we need to say, okay, in the field, at the row, at the column, this plant has now become diseased. And will this work? So only the disease chance only doubles in summer. The disease chance only doubles in summer, even if the plant is next to multiple diseased plants. So it doesn't actually matter if the plant is next to a diseased plant or not in any season but summer. Maybe that's a bit of a weird requirement, but that's what we're asked to do. Remember what the goal of this subroutine is to return a value number of diseased plants. So we make sure to increment this variable by 1, and probably we need to initialize it to 0 at the start of the subroutine as well. Right, so that was quite a long solution. Let's see now. Is it going to work when we test it? Probably not, but then we're going to go through and we're going to debug it. So let's just do the next bit. So we need to update simulate 1 year. So it calls simulate disease. So simulate 1 year. We've got the disease chance before simulating each season. So before running the simulation function for each season. And at the end of each season, we need to display a message saying disease affected diseased plants this season. So we need to run the simulate disease subroutine, passing in disease chance, field, and season for every subroutine. And then displaying subroutine. So simulating the disease and printing the number of diseased plants before displaying the season. Okay, so I think that's the solution to task C. Run the test. So again, it's going to say 25 by 25, but we don't have the variable field length, field width feature in place because that was a different question. So let's just test it with the constant, the 35 by 20 field. And we've got some indentation problems. So again, let's remember how to do this. If we want to change it to spaces and replace tabs with spaces, or we could do it the other way around. That's converting everything so it matches. And we've still got the same problem. So it's affecting the check for disease subroutine. One benefit of using subroutines is that the error messages will clearly tell you what part of the code is causing the problem, right? And sorry, it's where it's called. Where is my indentation error? I've got tabs for some reason. Indent type, spaces, replace tabs with spaces. I thought I clicked on it. Let's try again. Okay, it's working. So we're going to have the standard field dimensions. We want to step through the simulation for 10 years. Let's not load a file. And start with a low chance of disease and increase the chance each year as the simulation runs. Let's try a chance of 1. So if there's a chance of 1, there's a very small chance that the program actually works. Let's fix this error. So we don't have this variable season in the scope of simulate 1 year. Okay, so we don't have a variable season because we just reference the season with a literal value. Make it so that we pass in spring, summer, autumn, winter. Try again. Start with a low chance. So if it's 1% chance, bugs. So I've got diseased and adjacent referenced before assignment. Have I spelt the variable name wrong? So if diseased and adjacent is bigger than 1. Oh, okay, so in which case I probably need to do it here, don't I? Because that check. Or I guess I only need to do that if it's a plant. I only need to do all of this if it's a plant. So let's just indent that in so it's inside this if statement. And that will work. Hopefully. Okay. Another error. So there's a problem with col because col in fact should be column. Let's try again. 1% chance. And yeah, so we didn't see any disease, but that's probably because there was only 1% chance of disease in that season. So let's try 5% this time. So the 5% chance of disease has made some of the plants become diseased. So let's just think if I got this the right way around. So this number, the randomly generated number, if it was smaller than 5, then the plant got diseased. I'm quite surprised that we saw diseased plants there, but I guess because it was summer, there wasn't any originally diseased plants. Let's just try that again. So let's see now, if we put in 1%, we shouldn't see much disease spreading. And let's try the other way around. Put in a high chance of disease, so 50%, and then we see lots of seeds. Let's do it one more time with 100, and then we see everything diseased. I think that's working. So that was implementing the disease feature of making it so that disease spreads throughout the crops. And you can see here that there's a much higher chance of it happening in summer because you got this feature of like doubling the disease chance, right? Okay.